Hey, good evening, everyone. Welcome to Pittsburgh.NET user group. We are part of the .NET Foundation. Please join us in meetup.com/PGHDOTNET. We have all the social links here. And we are delighted to have you all here to learn about the introduction to AI for developers. We have our presenter, Sam, with us today. And during the next 1 hour, we are going to look into all the introduction for AI, like how the developers can leverage that. And I will pass over to Sam here. Sam, welcome to the group.
Thank you. Glad to be here.
Thank you for taking time and joining us here.
Absolutely, my pleasure.
Thank you.
All right. Well, thanks again for having me, and hello to everyone. Good afternoon or good evening, depending on what part of the world you're joining us from. My name is Sam Nasr, and this is a session on Intro to Artificial Intelligence for Developers. A little bit about me. First, you can find me on Twitter or X at Sam Nasr. I've been a software developer since 1995, and technically I will be celebrating my 29th anniversary tomorrow. So it's been a while, been seeing a lot of changes. I am a senior software engineer as well as instructor for NIS Technologies, and I've been certified with a few certifications from Microsoft. In addition, I'm actively involved in the user group community, specifically with the Cleveland C# user group, as well as the .NET study group. In addition, I've authored several articles for Visual Studio Magazine. I've also produced content for Opsgility and LinkedIn Learning. So with all that, it had brought me to a 7-time Microsoft MVP award, which I'm very proud to have, and really enjoy doing this kind of a thing and reaching out to the community. So a little bit of a shameless plug for the Cleveland C# user group. We meet every month. The meetings are free of charge and open to the public, and we cover a variety of topics related to .NET. You can find all the meeting information posted at meetup.com at the link listed at the bottom of the slide. So without further ado, let's dive into this evening's topic, which is an overview of artificial intelligence. We'd like to discuss some of the definitions regarding many of the popular terms that you hear: neural networks, deep learning, AI, machine learning, and it kind of sounds like alphabet soup at the end of the day. So wanted to dive in a little bit deeper. Pardon the screen flicker. Wanted to dive a little bit deeper and discuss somewhat what this terminology means. So getting into neural networks for starters, if you recall, that was the very bottom of the slide. That is what everything else builds on. So neural networks essentially behave very similar to decision trees, where we have each circle as a node, and think of each individual node as its own linear regression model, where it's composed of input, it has a weight, a bias, and then it produces an output. Likewise, that node could also be making a decision in the end. So we give it some form of data, and then we get an output at the end, which could be a decision leading us one way or the other. So with that said, let's take a look at an example. Let's say that I am a surfer, hypothetically, and I enjoy surfing, and there are some things that I need to consider before getting into the ocean. So first, are the waves good? Yes or no? And I would give that, since they're good, I would give it a 1. If it's a no, it would be a 0. And is the lineup empty to get in? No, it's not. There's people waiting ahead of me. And then more importantly, let's say that I am surfing off the coast of Australia or South Africa. And I would ask, has there been a recent shark attack? And in this case, no would be a 1. It's the positive thing that I want to strive for. But all these things weigh differently, meaning if there's a shark attack, it's definitely going to deter me, regardless of whether the waves are great or if the line is completely empty. So there are some things that weigh heavier than the others. So I can say, for example, for the first item, are the waves good? I can set that to a 5, where I'm concerned about getting out and the waves have large swells and they come around often. That would be a cool thing to do. Is the line empty? It's it's not really a huge factor, but it is a factor. So I'll assign that a weight of a 2. And then has there been a shark attack? That I will put a weight of 4 on it to see if it's worth risking getting into the water or not, depending on the size of the waves. Now, if you notice, I set the shark attack to a weight of 4, whereas the waves are a weight of 5. So that shows you that I am a risk taker, willing to take a risk for the sake of the waves, and maybe lose a leg in the process, but sacrifices need to be made. The point that I'm trying to make is that all these individual nodes, they have different weights on them that will produce the end result. So looking at the bottom of the slide, we see that we have all the different factors and they're assigned different weights. And depending on the final outcome, it will essentially steer me into a specific decision. So we can look at all the individual nodes here as far as, are the waves large? Is there a line? Is there a shark attack? And depending on the weights and the value that comes out of that, it will essentially guide me into a decision whether I want to be able to go out or not. And so that is essentially what a neural network is. It's composed of a variety of different nodes that allow me to be able to make a decision one way or the other, depending on the weights that were assigned to it. So that's neural networks in its very basic and fundamental format. Now we take that and we go a little bit deeper. So for example, if we build a 3 or more if we have 3 or more layers of neural networks, that's essentially considered deep learning. So now we're doing deep learning where there's a lot of things that we're weighing together in order to have the final outcome. Then I can build on top of that and get into machine learning, where now I have some algorithms that automatically detect and be able to classify items together. For example, if I throw several pictures together, let's say there's a group of pictures of motorcycles and a group of pictures for cars. So throughout, the algorithm will eventually be able to decipher and classify those that are cars versus those that are motorcycles, and without my intervention. So that's one example of machine learning. Now I can take that and build on top of it. And now I am into the artificial intelligence layer, where basically this is a science that studies ways to build intelligent programs and machines to creatively solve problems in the same manner that a human being would. So take, for example, when I say, are the waves, how high are the waves? So obviously within the context of surfing, it knows, the algorithm would know that I'm referring to the size of the waves, and it would respond back intelligently and say 12 feet, 15 feet, what have you. So that has built on the variety of different layers that are composing of AI. So as we see in this diagram, we start out with the neural networks. When we have multiple neural networks, we essentially build a deep learning layer, and then we can take that and expand on it to be a machine learning algorithm or layer. And then we take that, add more intelligence to it, and now we have AI where I can communicate with it just like I communicate with a normal person. Meaning, I don't have to phrase a question in a specific way or a format, but rather I talk to it with natural spoken language, and then it's able to reply back in the same manner as well. So I'm going to pause here for just a moment and ask if there's any questions. And let me take a peek in the chat window. And so far, I don't see any. I should also mention, feel free to jump in with any questions or comments at any point in time. Despite the fact that it's virtual, I'd like to make it as interactive as possible. So with that said, let's jump into some additional terminology. So when we're talking about artificial intelligence and machine learning specifically, the inputs that we provide to the machine learning model, that is considered a feature. So let's take, for example, the surfing example. Some of the features might be the size of the waves, whether there's a line or not, but let's take it a step further. Let's say that I'm doing linear regression on the price of homes. What is the price of a home dependent on? Well, the number of bedrooms, the location, other amenities within the home. For example, does it have a jacuzzi? Does it have a steam sauna, home gym, et cetera, et cetera? All these things are features that built into the final price of the home. And so these are the input values that we consider as features. Labels are essentially the output. So, for example, I would say a home in the greater Cleveland area in zip code XYZ would be about 450,000, given that it's 3 bedrooms, 2 baths, et cetera, et cetera. So that would be the output. Now, if we focus for a second, I gave you 2 different algorithms or 2 different types of predictions. One that involved my either going surfing or not, and another one was predicting the price of a home. So these are different types of predictions, but essentially what it takes is a feature or input value, and then it provides an output value. Some of them require to be trained, or let me rephrase that. Some of them require that it's supervised learning, meaning I give it the final value. Some of it where it can do classification by itself, like it can decipher cars separate from motorcycles. And that would be unsupervised learning. So I gave you 2 examples of types of predictions that we can implement, but in reality, there's many more to it. There is the classification and categorization. There's linear regression, like we talked about for the price of a home. It can also detect anomalies, which I had a perfect example of an anomaly earlier today. I received an email from Azure because I had stopped a service that kept accruing significant cost. I stopped it yesterday, and today I received an email saying there's been an anomaly detected. You have a sudden drop in the pricing on your Azure account. Same thing could occur for your credit card bill. Let's say every week you go over to a specific gas station, you fill up with about $50 worth of gas, and then all of a sudden there's an anomaly where it's $150 worth of gas purchases within the course of 2 days. That's obviously something that is not of the norm. There's also other scenarios where, like recommendations. I'm sure we've all heard of a website called Amazon.com, where every time you click on something and you purchase it, it also makes other recommendations to go along with it. So, for example, if I am online and I select to buy a mouse, naturally it's going to recommend, well, how about a mouse pad? How about a laptop to go along with it, et cetera, et cetera. And then there's time sequential or time series sequential data, which is basically allows me to be able to forecast sales and be able to identify high and low peaks. And then one of my favorites is image classification, where I touched on that earlier, where essentially you have pictures of cars and motorcycles or vegetables and fruit, and it's able to separate the two from each other. So let me pause once again, take a look in chat. Don't see any questions. So let's continue getting into it. So if I have, the first thing that I need to do is to be able to develop a model. Now that term has probably been used multiple times in the past. If you worked in MVC, you know the model means it's a database. If you work in SQL Server, when we talk about a model, it's how we're modeling the database. But now model development is referring to the AI model. Essentially, what the model represents here is that black box where we feed it input and we're getting output from it. So we need to be able to train it, have it be able to recognize our data that we're giving it to it, and then depend on it so that it gives us the proper output. So this is a very reiterative process. So as you notice in the diagram, at the very top, we have collect and load data. And let's assume for the sake of argument that the data that we're collecting is correct. There are no duplicates or erroneous items. And once we have that data, then we can create a pipeline. And then you see at the in the middle of the diagram, there's a train model box. And we do that using the fit method. So now we're giving it input values. We're giving it the output values of what it should be. So for example, I say that a 4-bedroom, 2-bath home in area code 44114 is 400,000, hypothetically, okay? And I give it all this data of all my housing information with the features and so forth. And then I train it, I execute the fit method, and it will look at all the features. It'll look at all the output values or the labels and be able to develop a linear regression model out of it. So then later I can ask it, well, how much is a 3-bedroom home with only 1 bath? And dependent on the data that I gave it, it can produce an accurate result in the end. And so after I train it using the fit method, I essentially need to evaluate it to see if all the data that I fed it is correct and that my model is ready for production use. If I evaluate it and I'm not satisfied, the process reiterates again, where I collect more data, set up a pipeline, train it, and evaluate. And hence it becomes cyclical until I'm satisfied with the results. When I am satisfied, I am now ready to use that model. And so I would save it off, and I would use the save method as you see at the bottom of the slide. And then that model is now ready for use. And when we say it's ready for use, essentially through any project, I would execute the load method. And then from there, I can make a call to the create prediction engine class, and more specifically, the predict method within that. Obviously, there's some more things that go along with it, such as setting up the sample data and passing it into the prediction engine. So how do I get started with that? So in the .NET world, obviously you'll be using Visual Studio, and we're going to create a sample application. What I need to do for my setup is make sure that I have the ML.NET model builder installed. And so specifically, if you look at this slide where I have the .NET desktop development environment loaded, but more specifically, if you look over on the right pane, I have ML.NET model builder selected. And this will allow me to implement the model and be able to train it and utilize it. Once I have that added, there are multiple ways that I can utilize a ML.NET model within my .NET project. So I can do it using the UI, which we'll step through in just a second, or I can do it programmatically, where I can incorporate the Microsoft.ml NuGet package, or if I'm a command line wizard, I can utilize the CLI to be able to do that. So multiple ways of utilizing ML.NET in your application. And like I always say, the best way to explain something is by demonstrating it. And so with that, we're going to jump into Visual Studio. Let me go ahead and open up a new instance of that. And I'm utilizing Visual Studio 2022. And I'm starting with a brand new console project just to show you that I have nothing up my sleeves. And what we'll do is we'll select console application. And let's call this ML demo.
I'm sorry to interrupt. There was one question, if you would mind. Take it.
Oh, absolutely. Let me go ahead and take a peek there.
It's saying that he's been working on some AI with C# and Python. Next one is a question.
Does duplication in the initial data set affect quality of prediction in the model is able to come up with? It can, depending on the trainers that you're using and the algorithms, it may, yes.
Thank you.
All right, very good. And I appreciate your questions. Again, feel free to keep them coming, as well as comments. And so with that, I'm going to make sure that I have the right path. So I'm going to create a demo folder here. We're going to select .NET 8. And it's going to take a moment to run. And there is my the project that I had just created. Again, it's a console application. There's nothing in it. So what I will do is I will right-click on the project itself, and then I'll select Add in Machine Learning Model. And the reason that this is available is because I did the prerequisite steps of installing the ML Builder in my .NET desktop development environment, as I showed you earlier. So we'll go ahead and select that. We'll keep the default name of mlmodel1.mbconfig. And now it's going to walk me through a GUI of basically what type of scenario or prediction do I want to do. And you'll notice that each one specifies whether it can be done locally or if it can be done locally or in Azure, so that I can utilize the computing power of Azure without having to waste my local resources. And so for this specific scenario, I'm going to select data classification. And then it's going to show me the environments that I have available for my local environment. And then next, I will select the data file. And so this data file is essentially comments that were downloaded for a fictitious pizzeria. And let me go ahead and share that with you. So we see that it's a flat text file where basically it has the comments as well as an indicator whether it's toxic or not. So, wow, love this place. That is a positive comment, so it's assigned a 1. Crust is not good. That is assigned a 0, so on and so forth. And I think I have about 1,000 lines in here, if I'm not mistaken. Yes, 10,000 to be exact. Oh, I'm sorry, I misread it. 1,000. So it's a CSV file where, tab delimited rather, that shows all the comments as well as the output, whether it's positive or negative. So going back into my project, I'll go ahead and select that file. And it shows me a preview with the first column and the second column. And now it's asking me, which column do you want to predict? And here we're talking about the label. So that's the output. And so typically it would show me the columns down here. Let's try that again. Okay. And of course, as expected, things don't always work in the demos. And so with that, let me fall back on another demo that I have. And let me close this one. So again, the scenario that I selected was the data classification. The data that I have is pointing to the Yelp label text file. And now I specified that the column that I want to predict, the label, aka my output, is going to be column 1, as seen over here on the far right. Then I'll move on to the next step, which is training. And I'm going to train it for 10 seconds. And then I'll select train again. And the reason I'm selecting train again is because I already ran this example previously to make sure that I had a working demo. And so you'll notice the training time as it was executing. Let me show you in the lower pane. Basically, it was stating that it ran through these trainers. And what a trainer is basically a combination of an algorithm as well as the task. So here we're doing classification of text, and it went through different algorithms trying to decide which one is best for predicting future text. And so it came back with the best accuracy of 0.79, which is relatively high. And it told me the best model was the FastTree OVA. And the training time it took was 8.4 seconds, even though I had assigned it 10 seconds up above. Now it's prompting me for my next step. which is to evaluate it. So it pulls off one example, and I can run it through the model. And the example here is crust is not good. When I ask it to predict it, comes back with a 92% confidence that this is a toxic value, or toxic comment rather. And then it's giving me the macro accuracy for the model is 0.79. So at this stage, I'm satisfied with the results. I'm ready to move on. I click next step, and then in the next tab, consume. So I can consume this in a variety of ways. It's giving me a code snippet here where I can utilize it. In addition, it's giving me the ability where I can add it as a console application or add it to my solution as a ASP.NET Core API. So if you'll notice, right now I only have the console app in my Solution Explorer. Once I select console application and add to solution, what name do I want to call it? We'll keep the name ML Model 1 console app, select add to solution. And there you see it added another project with the mlmodel1.mb config, which is the same one that was specified up above. Then I can move on to my next step, where I can deploy the model and put it into production, or there's some additional reading about how to improve the model and the accuracy. But at this stage, I'm essentially ready to go. I have it in my application as a separate project. And if we look at the program.cs there, we'll see that we have a ML model, ML model 1.mb config. And there's some additional files that go with it for the consumption. But more specifically, looking at this program.cs that it automatically created for me, it put in the right using statements. It set up my sample data. And we're going to give it a column 0 of crust is not good. And then we're going to make a prediction. And we make that prediction by making a call to the ML model 1 and pass in predict all labels. And then it's going to produce a score for us with that data that was provided. So now we can set this as our starting application. And we'll go ahead and hit run. And there it shows me that the crust is not good. It was the sample that I submitted. And the score that it came back with is 0, meaning that it's toxic. And then it shows me different algorithms and the confidence that it came back with a score. Obviously, the top scoring algorithm had a 91, almost 92% accuracy level. So there, I took data that I already have, hypothetically, and we all have data in our organizations. I took that data. I have the column specifying whether it's toxic or not. I used that for my training, and now I have an application that can predict future output of any comments that I enter in. So let me pause here and ask if there's any questions. Going once. All right. Again, any questions pop up at any point, feel free to jump in. All right, so getting back into our PowerPoint, if you notice the training time, I just used it as 10 seconds. And this is a recommendation made by Microsoft that obviously, depending on the size of the data and the type of data, it could take a significant amount of more time. The more critical part is making sure that my data is clean ahead of time. Now, to improve performance, there's a variety of things that I can do. I can give it more data, but more importantly, I can give it clean, meaningful data. And so for this example, it was basically a comment, toxic, not toxic type of output. But take, for example, linear regression for housing prices. Obviously, I can't just put zip code and price because the price of the home is dependent on many more things than that. So I need to provide it with meaningful data within the context, such as how many bedrooms, baths, is the home fire damaged? Is it livable, move-in condition? The zip code that it's in, et cetera, et cetera. So I have to provide a data with context, as well as making sure that my data itself is clean, that I don't have null values, that I don't have duplicates, or erroneous outlying values. In addition, I can utilize something called cross-validation. And what this allows me to do is to be able to split up the data into several different partitions, train it on train it using multiple algorithms, and then be able to identify the best algorithm for that from that data that was gathered. In addition, I can try different algorithms. So as you had seen in the demo, basically it ran through different trainers, which are algorithms looking for different tasks, dependent whether it's image classification, text classification, regression, what have you. So running through those different algorithms and making sure that I have the best fit is one of the best ways to find out how to improve performance. So again, this is a list of the different scenarios that I can do with my machine learning. It's not just linear regression or categorization, but there's a variety of other things that I can select from the get-go in my ML model. I also wanted to step through another example. Now, if you recall that there was something called Azure Cognitive Services, and that essentially has been morphed over into Azure AI services under a new name with additional services. So one of my favorite features is utilizing the text features. More specifically, it's within the speech service, but it offers a variety of different text-to-speech, speech-to-text, as well as speech translation. So let me go ahead and demonstrate some of that. And essentially what this involves is setting up the speech service on Azure, getting the key and the subscription. And as you see here, allow me to enlarge my code. I stored those off in my configuration manager. Those are supposed to be kept under lock and key, no pun intended. But I store my region and my subscription. Those are my keys for accessing my service from Azure. Once I do that, the code is fairly simple. And this is an example as seen here, text-to-speech.cs. What this allows me to do is to be able to take text and convert it to speech. And actually, because of possible audio issues, let's do this. Let's go to the speech translation. So there, essentially, it's very similar, where I have my subscription and my region stored in my in my app settings file, and then I am setting the language of.
Sam, are you sharing a different screen, or are you still in the?
Oh, my apologies.
Okay, so I do have a couple of questions since I interrupted you. Maybe we can
Sure.
go through that quickly. What happens if I type something else like pizza was burnt?
So dependent on all the other data that was provided, it may be able to pick up on it or not. Meaning, as you run it through the prediction, and let's go back here. If I go into my ML model and I go into my evaluate, and the text was pizza was burnt. and I click predict, it's going to give me results back, either 0 or 1. So it is 72% confident that this is a bad comment. And again, this is dependent on how well you trained it. So I gave it 1,000 examples of various texts. This is where I do my evaluation and run through several examples. Obviously, running through 1 or 2 examples is not sufficient, but I have to squeeze it into a demo that's only an hour long, right? So I can't continue to predict or run predictions to evaluate it. In reality, though, you'd want to run many examples to make sure that it's up to par before migrating it to production.
Thank you, Sam. Back to you.
Thank you. All right, so back to our speech services, and let me go ahead and enlarge the font a bit. So there's some NuGet packages that I need to utilize here, and essentially getting my subscription and my region from my config file. Now, the next thing that I'm specifying is what language does it need to recognize, and I set it to English US. And then the target language, I'm going to be a little bit greedy and ask for both Italian and French for the translation. Then I will specify where I want that audio input to come in from. And then I'll make a call to the translation recognizer. And then what this will do is we'll enter into an infinite loop where essentially it's going to tell me to speak into the microphone. It will then take that and make an asynchronous call to the service so that it recognizes my speech. And then it will output the translation results. And this is a method that is called down here. So we pass it in the translation result that we got from Azure, and then we scroll through, and essentially this displays what the results that were found. If nothing was found, then it displays the error codes down here. So let's run through an example. Here's my console window, and it should recognize the text that I just spoke. And there translated all that into both Italian and French. Let's try a simpler example. I love pizza. So this is another low-hanging fruit that you can implement with the speech to text, because now this way, if someone is visually impaired, they can walk up to a kiosk, be able to feel their way around to press a button and be able to speak into it. And now you can interact with the user just simply by speech. So here we saw how we can take input and be able to translate into text. Likewise, we can do the opposite. And another example is, so this was the translation. We can take text to speech, and let's change to that project. And because I already have my service set up in Azure, I'm utilizing the same subscription and region keys. And then I am now, it's a little bit different in the sense that since it's going to be speaking to me, I have to set the voice. And I chose a gentleman by the name of Connor. And so this voice setting is called Connor Neural. And as you'll notice, there's a variety of different voice settings, and you can see a full list over on Microsoft.com. It will then take that text and then make a call to the speech synthesizer. And now I can, it will take that text and be able to speak it asynchronously by making a call to speak text async. So let's run through a demo of that. And let's remove the breakpoints.
Can you hear me?
I'm not sure. Did the audio come through?
It did come through.
Excellent.
Please say hello.
So as you see, the choice that I preferred was a male voice with a relatively straightforward American accent, if you will. Like I said, there's a variety of different voices to choose from: male, female, different countries, different accents, etc. Any questions so far?
I don't see any, Sam.
All right. So we talked about how we can build an ML.NET project using data that we have and be able to identify various things, whether a comment is toxic or not, be able to do linear regression. Another thing, relatively low-hanging fruit, is to be able to converse with our user either by text or by speech, and vice versa, accept either text or speech for dialogue with the application. Another thing that you may have heard of is co-pilots. And what co-pilot is essentially the ability to utilize what's called a large language model, which is what we've seen here are relatively small models that we built. But if you take a large language model, something that's built off of the internet, various facts that are found on the internet combined into a large language model. But then I can take that large language model and have it customized specifically for my data. So now I can converse with my application. And to give you an idea, let me pull over this browser. So there's a new product called Azure AI Studio, relatively new. And what this allows me to do is to be able to work on a large language model, and I can customize it. So this is what's called the chat playground, where I can do my evaluations, I can test it, and I can also specify how I want my model to behave. So as you see here, it says you are an AI assistant that helps people find information. I can change that and say you are a comical and funny AI assistant that helps people find information. And then I have a message that came up here that says, please select apply changes. Why am I not seeing that? Okay, let me refresh.
Sam, while we wait, there was one more question.
Sure.
Okay, so it's a language model.
When you say language model, which one are you referring to? What I'm doing here?
Maybe I think it's the previous one that you were showing the demo.
With the speech text translation?
Yeah, I would think so. Maps, if you can be more specific, it'd be easy for us to answer that.
So actually, I'll answer both. So for the speech to text or speech services in general, that is just a service offered by Microsoft, and everything else, the model within it, that's kind of a hidden black box for the most part. And so I specify which language I want to recognize. So for example, the speech translation, I want it to recognize English US, and then I need to translate it to Italian and French. So this is already part of the Azure service, and it just translates it for me. There are some modifications that I can make, which are relatively advanced in the sense that I can have it to tweak the response with certain accents. I can have it to respond to certain words depending on the dialect and the country that I'm referring to. Here, I just kept it English US, plain and simple. So as far as language goes with the speech recognition, that's all built into Azure. I really don't have a whole lot of control over it. As far as within Copilot, And let me pull up the right window. So this is called the Azure AI Studio, and I'm in the chat playground, which is essentially my sandbox for evaluation. Pardon me. And so what it allows me to do here is to be able to take a large language model. And here I selected GPT 3.5 Turbo. I used GPT 4.0 model for other things in the past. But essentially, you select the model from a variety of different models that are available. And to give you an idea, let's go over into the model catalog. And we see we have 1,700 models, over 1,700 models to choose from, large language models. And you can filter on these depending on the collection, whether it's from NVIDIA, from OpenAI, Databricks, et cetera, et cetera. There's also various deployment options that you can choose from. And then the various tasks that you need to perform, whether it's text classification, translation, et cetera. So hopefully that covered the answer, whether you're referring to something using the large language model in the AI Studio versus the translation that we used in speech services. And if you need more clarity, again, I'm open for more questions. Likewise, I will share my contact information afterwards. So getting back into our chat playground, another feature, and I'm kind of fast forwarding into the demo because explaining this is a course by itself, getting into the Azure AI Studio and large language models. But I can quickly implement the large language model where I can now ask it a question. How many US car makers are there? So this is a general question. And if for comparison, first I'm going to submit it here. And then it responds back, pardon me, with some meaningful text in natural spoken language. Likewise, I can also have it speak the response to me. Let's do keep it United States, enable text to speech, select the voice. So as we see, I asked it a natural spoken language question, and then it responded back with natural language as well for the response. But now if I go to something like Google, which I'm sure we've all used before, and I ask it the same thing. Now, as of lately, they've incorporated this AI overview, but beforehand, you'll notice that all I had was just a choice of links to choose from, where then I could derive the right answer from it, as opposed to directly in my co-pilot, where I enter it in, I'm utilizing a model of my choice, and it gave me the proper response back in natural spoken language. Now, to take it a step further, I also have the ability to add in my own data. So let's say, for example, I have a company where we sell hiking boots. I can train it on that specific data for product info. Pardon me. And then I can deploy an application. And once the application is deployed to the web, you'll notice that this is on one of my Azure websites. Now I can ask, how much are the Trail Walker boots? And it responds back, the price of the Trail Walker hiking shoes is 110. And then I can further ask it another natural language spoken question and say, are the Trail Walker boots stylish? It'll take a moment to generate the answer. And then not only does it respond back with the answer, but in some cases, it also gives me a reference of where that answer is found. So for this specific scenario, it doesn't provide any information about the style, but let's ask it another question. Are the trail walker boots comfortable? And again, another generated answer where it says, based on the reviews, they're generally comfortable. And then it goes on with some additional information. Then it provides me a reference to this document. And the part that I didn't mention is that, like all other models, I can train it on my own specific data. So ahead of time, I trained it on this product info file, which is basically information regarding the trail walker boots, and it's a markdown file, hence the .md extension. But I was able to train it on my own data, and now I have a search engine utilizing a large language model that produces answers specific to my product and my line of business. Any questions on that? All right, fairly quiet crowd tonight, but I would happily share my contact information. And so let's get back into the remaining slides. So some gotchas regarding the ML.NET application. That's the first example where we developed our training model based on the text that we gave it for our pizzeria. So one gotcha is that 32-bit is supported on Windows, except if you're using TensorFlow, LightGBM, or Onyx. These are different frameworks for machine learning. Likewise, in previous versions of Visual Studio, I used to get this error where when I'm adding on a new project, that it tells me that it is not supported and that I need to utilize the x64. So with that, we talked about Azure AI services regarding the speech and vision. In addition, there's a variety of other things you could do. So vision and decision making. We talked about speech. You can also use it for language recognition. And then a variety of other open AI features. Let me just skip down to some other things that I wanted to cover. So with regards to additional documentation and references, you can find the ML.NET guide over at Microsoft.com. In addition, there's the machine learning glossary. And then improving ML performance. That was similar to what I had mentioned about getting more data with context, cleansed data, etc. So if you found this helpful or as a good stepping stone and you're interested in having this as a course, NIS Technologies does offer this as a course if you're interested. All courses are instructor-led, either in person or virtually. And as far as my contact information, you can find all my socials on Linktree/Sam Nasr. But more specifically, feel free to reach out to me. My email is snasr@nistechnologies.com. You can also find me on Twitter at Sam Nasr. My blog, where I blog about different AI and machine learning articles, samnasr.blogspot.com. And lastly, if we're not connected on LinkedIn, I invite you to do so. And so with that, thank you all for attending, and thank you for having me. And I really sincerely hope that we keep the conversation going. Just because the meeting is coming to an end doesn't mean the dialogue stops here. I really enjoy reaching out to other people. The internet has made the world a village. We just email or set up a virtual conference call, and we can connect. I can help you get started with an ML project or get going into AI. It would be my privilege and honor to help you. And so with that, thanks again for attending, and please keep in touch.
Thank you, Sam. It has been a pleasure hosting you. And well, if you have any further questions, like Sam mentioned, you can reach out on his social channels. I believe one last question related to the language model, Sam, that you were talking through. The question belonged to the first example.
The first example. So we were talking about the translation.
I would think so. Yeah.
Okay. So again, that's all encompassed within the Azure service that's provided there. There's very little leeway that you have as far as modifying it. There's a markup language that's used for modifying the accent when it's referring back, when it's speaking back to the user. But aside from that, all that is just, it's handled on Azure Speech Services.
Perfect. Thank you very much.
Thank you.
Thanks everyone for joining us, and we'll see you next month with another topic and an excellent presenter. Thanks everyone.
Very good. Good night, everyone.